forces that are acting on a ramp. And how we're going to do that is we're going to use this simulation over here, which is going to allow us to adjust things on a ramp. And so what we're going to do is we're going to take our friction down to 0. We're just trying to look at how the forces break down when something is on a ramp at some angle. Initial velocity, we're going to go ahead and set to 0. Gravity, just 9.8. Mass at 3, or really this value you can change however you would like. I just have mine set up as 3 or 4.3. Doesn't really matter what that value is. Okay, and then we're going to set up a data table that's going to look like this. And what we're going to do is we're going to find the mass of the box. So mine was 4.3. The weight of our box then is going to be the force of gravity. So if this is my mass, my weight is going to equal 4.3 times 9.81. So that's my weight. And then what I'm going to find is the acceleration on the ramp. And this is going to be the net force pushing the box down the ramp then. So what you'll see is you'll be able to change your angle here. When we do that, we really don't even have to run our simulation. It's just going to give me an acceleration right here. So I can say for 10, that's going to be 1.702. And then what I can do is I can say, well, the net force then is mass times acceleration. So if this is the acceleration that it's experiencing, the mass is 4.3. So I'm going to say 4.3 times this acceleration. And really, I'm going to use this for every single one, and I'm always going to have the same mass. So I'm going to put a $ in front of the B and the 1, because I always want to use 4.3 for my mass. And then really, I can just drag this down. It should show up as zeros now, but that's because I don't have any values here, right? If I were to plug in values there, it would do that calculation for me. Then all you guys got to do, and really it doesn't have to be 10, 20, 30 all exactly, right? I just know that that's typically how we're going to do things. I'm just going to come over here. I'm going to change the value. Here, obviously, my acceleration would be 0. So the net force here would be 0. And then I'll just go to some random value here. Boop. All right, what did we get? 41.9. So I could change this. 41.9. My acceleration would be 6.545. I'm going to go out to at least 1 decimal place. 3 sig figs for these. And that's what I got, okay? And so you're going to do that for all of them. That shouldn't take super long. Then what I'm going to do is I'm going to kind of create a graph. And that graph is going to be highlighting these two. So I want the angle of my ramp. What did I control? My independent variable is the angle of my ramp. What's the dependent upon that is the net force. So I'm going to do that. And then I'm going to add a chart. Okay. And so we'll add that chart. It's not going to look very great for me right now, just because obviously all my data are zeros. But it's going to create a shape that is not linear, right? It's going to have a shape that looks kind of concave down as we're going through it. So what we're going to do is we're going to linearize that. And that's a process that we do in math or in physics. And so to linearize that, what we're going to do, I'm not sure why those are. Okay, so to linearize that, basically what we're going to do is we're going to take the sine of my angle. And to do that, I'm going to do equals sine. So this is going to be an angle provided in radians. So I need it in radians. So I'm going to type in radians. And what that does is that converts an angle in degrees to radians. And then I'm going to click here. And that's how I'm going to turn this value of degrees into radians. So this is just the sine of my angle. I'm going to then pull down. And you'll see basically I've done that for all of my values. Okay. And then I'm simply going to copy and paste these values down to here. And we're going to now plot this as well. So you're going to make two graphs. And this should be a linearized graph. We'll give this a title of net force pushing box down the ramp versus sine of our angle linearized. Okay. And so I should have two graphs. One of them is going to be the net force versus just the angle of the ramp. And the second one is going to be the net force versus the sine of our angle. And so that's going to be our linearized graph. Okay. Not sure why these showed up as 4. Really, these values should be the same as these values. So yeah, we don't want that. We want these values to be the same as this. So I'm just going to, instead of this, again, 1 times that acceleration. So while that looked nice and linearized, it's not what it should be. These numbers here, right? These numbers here should be the same as these values there. All right, and we're just going to compare them to the sine map. So by the end of the class today, really, you guys should be able to go through this and then create your two graphs. Again, this one should be a nice straight line. And with this one as well, we're going to make sure we have a line of best fit. So we're going to do a trend line, linear, and we're going to use equation. And you can show the r squared. R is right now, obviously this is not going to be very nice. We don't need to do that for this first one. It's not going to be a linear graph. And then we'll talk about kind of why we do this in physics and what these two graphs can tell us.